Hi students, I welcome you all for the session. So I'll be starting a new playlist. So that is Aptitude Class. So this playlist contains the basic understanding of the aptitude. So this is for the beginner. Okay. So we'll be going to discuss some important topics. So for the exam point of view. So these concept will be very important in the exam point of view. Those things I will be covered in this aptitude playlist. Okay, the first concept I'll be going to discuss today is operation on numbers. Operations on numbers. So in this content we'll be going to discuss so what is the meaning of face value and place value, and we'll be going to discuss about the divisibility by numbers. So divisibility of a numbers. Okay, divisibility of a numbers, and we'll be going to discuss prime numbers. So how we have to identify the prime numbers. So all these contents we'll be going to discuss in this aptitude, and we'll be solving some important solutions. We know about we are having 10 digits. So those numbers are called 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these 10 digits are we have been expressed in Hindu Arabic systems. So now, so if numbers, these numbers will be written in a, if these numbers in written in a group. So group means what? More than once. The value contains more than one. Suppose we are writing these numbers. So these numbers will be called as a group of numbers. So it it will be called as numeral. So it will be called as numeral, and is given number. So sometimes in examinations you will be asked to find the right a value of a face value and place value of the these numbers. Face value are those numbers. Face value are those numbers which is having a same value, which is having a same value. Suppose face value of 5 is 5 only, and face value of 2 is 2 only, and face value of 3 is 3. And but in case of place value, so place value position, so which is at which position. So we know about in mathematics generally. So you need 10 digits and 100 digits. So this one you know. So that one is called a place value. So place value of, I'm writing here, place value of 5 is what? 5 into unit digit, right? The 5 is at a unit position, and 2 is at a 10 10 100 the 2 is at a 10 tens digit, and 3 is at a hundredth digit. So 5 into units, 5 into a unit digit, right? It is unit digit. So that will be called as 5. And what is the place value of 2? So place value of 2 is what? 2 into tens digit. 2 into tens digit. So it is 20. And the what is the place value of 3? So 3 into hundreds digit. Hundreds digit. So it is 300. So this is the meaning of place value and face values. Suppose in time, sometimes, so sometimes it will be given. So sometimes I will writing here. So in a table, right? We are having unit first and then 10 digit and 100. So 100 and after 100 is 1000. So 1000 after 10,000. So and then 10,000, and next we will be having lakhs. So 10 lakhs, and crores, 10 crores. Suppose I'm giving here an example. So here I'm writing a number 63638,549. So what is the meaning of this? 6,38,549. We can write this one in a word. So it is a 6,38,549. Okay. And sometimes, so from this table, so from this table, so we have to write in a words. And sometimes, so it will be given as in sentence. Okay, sometimes I will be given a sentence: 10 crore 45,000 300 in a word I'm giving 300. So this the sentence in word I am writing here in a table. So how can I write here? 10 crore is there. 10 crore means here 1 0 and 45,000. 45 means 10,000. So here 45,000 and means it is 00 here. So 00 and 300. 300 means here 300. Okay. So likewise, like this we can uh, present a numbers in a table form or in a word form. Now we'll be going to discuss various types of numbers. So various types of numbers. Generally, uh, we know about natural number and integers, real number. Those all called as a types of numbers. Okay, types of numbers. So natural numbers are those numbers. So natural numbers are those numbers which containing positive values other than the zeros. So zero is not here. So other than the positive values are the natural numbers. And whole numbers means what? Whole numbers, it contains zero and positive values. So it considering the zero and positive values. It is called whole number. And what is about integers? So integer is a number which consists of both negative values and zero and positive values. So this one we are calling as a integer. So integer generally will be denoted by a number z, capital Z, and natural number is denoted by a symbol capital N. Okay, and whole number will be represented by a capital R. So now we'll be see the what is the meaning of even number and odd numbers. So now we'll be going to discuss what is the even and odd numbers. So even number means the number which will be divided by 2. The is number is divisible by 2, such numbers called even numbers. The examples of those, so 0 2 4 6 8, these are the even numbers. Even 0 is also even number. Suppose in example in any number is containing the 0, so 20 30, so 40. So here we are containing zeros, so these numbers will be divided by 2. So okay, it will be divisible by 2. These numbers are divisible by 2. 10s are 20, 2 15s are. So these numbers are divisible by 2. So 0 to 4 are called as a even numbers. And odd numbers means, so the number which are not divisible by 2. The number is not divisible by, so divisible by 2. So such numbers are called odd. So which are the numbers? So 1 1 1 3 5 7 9, right? These numbers will not divisible by 2. So 1 by 2 it is not divisible, 3 by 2 it is not divisible. So such numbers are called odd numbers. Now the very important topic we'll be going to discuss, prime number. So what is the prime number? So prime number is a counting number. So it is a counting number such that the numbers is divided by its own, So the number is divisible by only, is divisible by its own number and 1. So prime number is a counting number which is divisible by only its own number and 1. So we'll see the which are the prime numbers. So here every numbers, you must understand that every number is which is divisible by 1, right? So 1 is not a prime number. So take 2. So 2 is only divisible by its own number, means it is divisible by 2 and 1. So it is a prime number. 3. So it is only divisible by 1 and 3. So it is a prime number. 4. So 4 is not a prime number. So 4 is a not a prime number because it is divisible by 2. So what about 5? 5 is not 5 is a prime number. 6 is not divisible. 6 is not a prime number because it is divisible by 2. So 7 is a prime number. 8 is divisible, it is not a prime number, it is divisible by 2 also, 4 also. And 9 is also not a prime number, it is divisible by 3. 3 nines are, so it is not a prime number. So 11, 13, so these are the prime numbers. So which are the prime numbers? 2, 3, 5, 7, 11, 13. Okay, 13, 14, 14 is not a prime number, it will be divisible by 4. 15 is also divisible by 4, like so on. We can write a list of prime numbers. Understood? What is the meaning of prime number? You understood. Now I will be give one example here which is very interesting. So we have to find which are the prime numbers. So which are the following are the prime numbers? Which of the following are the prime numbers? So here I am giving an example. So we have to check this is a prime number or not. So 137, 173. So third one is 319. Fourth one is 437, and fifth one is 811. So usually 137 is divisible by any other numbers, right? Any other numbers other than by its own number and 1. So to check this one, we have to go not a randomly. There is some such one formula is there. So to find a prime number, so usually we following a formula: n square is greater than or equal to p. So p is means what? Prime numbers. So if any n square is greater than greater than or equal to p, so then we can say this prime number is prime number or not. So we'll be understanding here. Suppose you take n square. So n square of when n square, it has to come either greater or equal. So what value we can take for the first one? So 137. So you take 137 means we'll understand. So 10 square is by seeing we'll understand 10 square will be 100, 11 square will be 121, and 12 square is 144. So which value we can take here? 121, here 137. It is 137 comes here in between. So this value we can take, greater value we can take. So it is for this problem one, we can take 12 square is greater than p, right? 12 square is greater than p. So 12 square is 144. 144 is greater than the p, right? So p is means what here? This prime number 137. 12 square is, so means what here? 12 square is greater than the 137. Understood? So to find this, so 12 here where we are having 12. So which are the numbers less than the 12? Which are the prime numbers less than the 12? Which are the prime numbers which less than 12? We have to write here 2, 3, 5, 7, and 11. These are the prime numbers less than the 12. And we have to check here these numbers divides 137. Okay, these numbers divides these numbers are divides the 137. You just check. Okay, none of the numbers are divides the So none of the numbers divides none of the 2, 3, 5, 7, 11 which divides 137, which divides 137. Therefore we can say 137 is a prime number. So 137 is a prime number. So prime number, what is the definition of prime number? It is divisible by its own number and by 1, and by other numbers it has to it by other number it will not divide. Such numbers are called prime number. Now come to the second one. So second one is 173. So which square number is near or equal or greater than this 173? So we have to recall formula here. N square is equal to greater than or equal to p. P is prime number, this number. So which number comes here? So we know about we just check that what is the 15 square. So 15 square is what? 225. So what about 14 square? So 14 square, if we take 14 square, so 14 square, 14 into 4 are 4, 4 are 16, 4 1s are 4, 56, 56 comes here, 14 1s are 14, 196. This is 196. So if 13 square is less than this number, but in between number, that one we have to take. So 14 square, this 14 square is greater than the p, right? This 14 square is greater than the p. So which are the prime numbers which are less than the 14? So those are 2 3 5 2 3 5 7 11 and 13. So we have to check these numbers will be divided, which divides 173. These numbers which divides 173. So clearly we can say that none of them divides 137. So clearly none of them divides 173. So we can say 173 is a prime number. So therefore 173 is a prime number. Okay, you follow the same method and find the other also. Okay, find the other also. So I will be giving here third one. Third one is here. Third one is 18 square. So 18 square is greater than 319. So here we'll be having, so this 319 will be divided by 11. So it is not a prime number. Okay, it is not a prime number. And 437 is not a prime number. And 811 is a prime number. You just follow the method and try to solve. Now we'll be go to the next. So divisibility. Okay, next concept is divisibility. So tests of divisibility. So tests of divisibility, here we have to check the numbers which will be divisibility by 2. The number is divisibility by 2, 3 and 9, 4, 8, 10, 5 and 11. So all these we have to see the conditions. So if any number is divisible by 2, how we can check this one? So if any number a number, okay, the first one is what? The first one is divisibility by 2. Divisibility by 2. So what is the statement here? A number is divisible by 2. Divisible by 2 if its unit digit if its unit digit if its unit digit is of any, so 0 0 2 4 6 8, these are what? Even numbers. So if any number contains these 2 4 6, the unit digit is even number, then we can say that it is divisibility by 2. So I will give one example here. So 5 8 6 9 4. So what is the unit digit of this? 4. So 4 is divisible by it is divisible by these odd numbers, right? It is divisible by 2. So it is divisible by 2 also. It is divisible by 4 also. Then we can say this number is divisible by 2. And one more example I will give here, 86945. So its unit digit is not a even here. Unit digit is not a even. Then we can say that. So it is not. This number is not divisible by 2. This number is not divisible by 2. Okay, understood. So now the second one we'll be going to discuss divisibility by 3. So okay, this divisibility by 3. So when we can say the divisible by 3, so a number is divisible by 3 only when the sum of its digits the sum of its digit the sum of its digit is divisible by 3. So if any number is given, if may be asked, it is divisible by 3 or not. So to if it is divisible by 3 or not, to check this one, so what we have to do, the given number we have to add. Suppose I will be give you example here. So 695,421. So this is divisible by 3 or not? How we can check? So for this we have to add all the numbers. We have to add all the numbers. If we add, so what value will come? 27. So 27 is divisible by 3 or not? Yes, it is divisible. 3 9s is 27. Then we can say as this number is divisible by 3. Okay. So same in the same way, for 9 also the third one condition, for 9 also divisible by 9. So divisible by 9, so we are having the same condition, that so a number is divisible by 9. So the sum of its digits is divisible by 9. Okay, so suppose I will be giving example here. So 246591. So what is the sum of these digits? Sum of its digits is 27. So 27 will be divided by 9, right? 9 3s is 3. So this number we can say it is divisible by 9. So it is divisible by 9. So another example I will give here. So 734519. You just add these numbers. So what will be get? 29. The sum of these numbers is 29. 29 will be not divided. It not divides 29. 9 is not divides 29. Then therefore this number we can say it is not divisible by 9. Okay. Next condition we'll be going to discuss, that is divisible by divisibility by 4. So when we can say the number is divisible by 4, that last two digits. So we have to check if number. So the last two digits, a number is divisible by 4. Its last two digits we have to. The last two digits is divisible by 4. Then we can say that number is divisible by 4. I will give example here. So 6879376. So this number is divisible by 4 or not? How to check? The last two digits we have to take 76, and 4 ones are 4, 3 remains, 4 8s are 36. Then we can say this number is divisible by 4. Okay, divisible by 4. So for the fifth one is the statement for the fifth one is divisible by 8. So when the given number is divisible by 8, so to find this one, last three digits. Okay, last three digits, its last three digit we have to check it is divisible by 8 or not. Last three digits we have to check. So suppose if any number is given, I will say here 16789 352. So we we have to check this number is divisible by 8 or not. So this number is divisible by 8 or not. To check this one, last only three digits we have to check. Last three digits 352. It is divisible by 8. Then this number is divisible by 8. So 8 4s are 30, 32. 3 remains 32. 8 4s are, okay. This number is divisible by 8. Then we can say this number is divisible by 8. Right. Okay. Next here we'll be going to discuss divisible by 5. So when the such number is given, then how to find it is divisible 5 or not. So its number, the unit digit will be, so if number contains the unit digit is either 0 or 5, then we say this number, the given number is divisible by 5. I will give example here 76895. This number is divisible by 5 or not. How to check this one? The unit digit is contain 5, so it is divisible by 5. Now suppose if any number is given by 0, it ends by 0, then we can say the unit digit ends by 0, then we can say this number is divisible by 5. So when we can say the number is divisible by 10, so when we can say the number is divisible by 10, so the unit digit is 0. If the number is contains the unit 0 is 0, then we can say it is divisible by 10. I will give example here 670 71890. So this number contains a unit digit 0, then we can say this is divisible by, this number is divisible by 10. Okay, understood. So the last one will be going to see the very interesting. So number is divisible by 11. Okay, number is divisible by 11. If given for a given number, so it is divisible by 11. How to check this one? So what we have to do? Difference we have to take. So difference between the sum of its digits. The sum of its digit difference between the sum of its digits at odd places at odd places, and the sum of its digit at even places. So if any number is given to, suppose I am giving number here 294, any big number is given 294 okay, so we have to check this number is divisible by 11 or not. How to check this one? What we have to do, we have to take the sum of odd numbers and sum of not sum of, so here sum of odd number minus sum of even places, even sum of its digits at even places, sum of its digits at odd places, and sum of its digit at even places. So the which are the odd places? So here these are the odd values. Okay, 1 3. Here the odd numbers, first number is odd, this is 2, second number that it is at even, third, fifth one. Okay, these numbers are odd numbers, this number, the number position at the odd position, then we will be taking that numbers, then plus 9 plus 3, 9 plus 3 plus 4 plus 7, 4 plus 7. Then the sum of digits at even places, So even numbers are 1 5 4 2, then 2 4 2 4 2 4 5 1 5 1. When we do this one, so we'll be getting here 23, and this sum will be get 12. 23 divided by 23 minus 12 is 11. So 11 is divisible by 11, right? So 11 is divisible by 11 was 11. So it is divisible. Therefore, this number is, we can say this number, the given number is divisible by 11. Understood? So now you understood the concept of divisible and not divisible, prime number, and the face value and place value. All these things we understood. Now we'll be solving some exercise, some interesting exercise we'll be going to solve. Suppose in your examinations is given to calculate the product of, okay, to calculate the product of, so product of 4093405 into 399 499. Okay, so how the multiplication of finding the multiplication of this number is very big. So we have to do some trick here. So what the, so this 499 we can write as we can, this number we can write as, so this number we can write as 1000 minus 1, 1000 minus 1, not 1000, 10,000. So 10,000 minus 1 we can write, can write or not? Yes, we can write. So we can write 10,000 minus 1. So here then we can multiply this number easily. So 5793405, here 1 2 3 4 zeros are, then I will put here 4 zeros. So then here 573, this number into ones are that same number 3405. Now we can substitute easily. Okay, this might be easy than this. Okay, this is into is very difficult. Minus we can do easily. Okay, minus we can do by writing this 57934050000. Then we can write this number here. So 0 50, reverse I'm writing, reverse these numbers, reverse I'm writing. Then we can subtract easily. 0 5 4 3, below number, each exactly below number I am writing 9 9 7 5. Okay, this minus this. Okay, then we can easily subtract this number. Okay, such tricks we have to follow. Okay, now we'll be seeing some so now we'll be seeing if any number is given 396 into 396, 1396. So how to find this value? So to find this value, so what 1396, both numbers are the same, then we can here 1396, it is a square, right? It is a square. So it is a square, then this number we can take as, this number we can take as this number we can take as a, so it is equal, it is near to 1400, then we can 1400 minus 4 we can take, right? We can take, so 14 square is what here, double zeros are there, and 14 square is what, 196. Okay, 14 square is 196, double zero is there, and when we are square, then 4 zeros are come, 4 zeros are come, right? So 4 zeros are come, and 14 so 4 square is what, 16. So 16, this is in the formula for a minus b whole square. This is in the formula of a minus b whole square. So what is the formula for a minus b whole square? A square plus b square minus 2ab. Okay, a square we have written here, b square written. Then now we have to write minus 2 into ab, 1400 into 4. Okay, now it is very easy to add these numbers. Now it is very easy to calculate this one, right? So this is over. And now next move to the next problem. Next problem. So here 475 and into 475 plus 125 into 125 is given. How to find this value? So these This is given in the, so the both numbers are same, both numbers are same, then we can write this number is 475 square and 125 square, right? 125 square, it is in the form of a square plus b square, right? It is in the form of a square and b square, but there is no formula for the a square and b square. We are having formula for a square and minus b square. What is the formula for a square minus b square? A square minus b square is what formula? A plus b into a minus b. A plus b into a minus b formula is there, but for this no formula is there. What we have to do, we have to write, we know about 1 by 2 of a plus b whole square plus a minus b whole square formula. We right, we know the formula of a plus b whole square, a minus b square formula we know. When we are writing 1 by 2 of a plus b whole square and a minus b whole square, you simplify this equation, so it is equal to same as this equation, a square plus b square, right? This is same as this we can write in this form, right? Both are same. Okay, both are same. So now it is very easy to calculate, now it is very easy to find these values, right? So here a is what? A is 475, then you can write 1 by 2 of 475 plus 125 and for plus 475 minus 125. Okay, therefore this is 1 by 2 of this. When we are adding, we will be getting 600 square, and this one will be get 350 squares. Okay, now we can simplify this sequence. We will be get the easy formula. So here 1 by 2, here 6 square is 36, and 4 2 double 0 will come as 4 double 0, 4 double 0, and then it is 35 square is what? 35 square is 35 square is 1225, and 1 0 is there, in means here 2, when we are squaring then 2 0 will come. Then for it is 1 by 2 of into 48,000 to 500, then it is come 241. You simplify this one. Okay, I'm just giving the trick how to find that one. Okay, now we'll be going to see. Okay, suppose if any equation is given. Okay, suppose here the 789 into 789 into 789 is given, so all three numbers are same, and then plus 211 into 211 into 211 is given, and here three numbers are same, and now we 789 into 789 minus 789 into 211 plus 211 into 211. So here we can observe that these are in the form of, this is the given problem is in the form of, so the three numbers are same, that it is a cube, so these three are same, so then we can say b cube, right? So here we can write a square, so uh, this is in minus a into b, and this is b square. So this given problem is in this form, right? The given problem in this form. So we know that the formula for a cube, and we know the formula for a plus b whole cube. What is the formula for a plus b whole cube? A cube plus b cube plus 3ab into the bracket of a plus b, and you just write down these formulas. A minus b whole cube, this is whole cube, but these are the a cube and b cube. I'm writing all the formulas here. Then the formula for a minus b whole cube is a cube minus b cube minus 3ab into a minus b. And what is the formula for a cube plus b cube? A cube and plus b cube formula is a plus b. So a plus b, a square. When plus is given here, then we'll be having minus of ab plus b square. And what about a cube and minus b cube formula? So here a minus b is given, then we have to write a minus b as it is, and the a square will come here. Minus is given, means here plus will come, ab. Okay, so plus. So this is the formula for a cube and b cube, and we put this a cube and b cube formula here. So we can write a plus b, a square minus ab plus b square. You have to remember this formula. And a square, this is in the formula a square ab plus b square, right? So now, so these, so this term both are same, then we can cancel this term. So only we are having a plus b. So a plus b is what? A is 789 and plus b is 211. Then we are having 1000. Value of is 1000, right? So this is correct. Now, okay, now in next class we'll be going to discuss some other topics. Okay, before that I will write some formula, other formulas. So I will write other formulas to calculate. So some, if, what is the formula for a series? The formulas on series. So formula on series. You just note down this formulas. Formula on series. If series means what? The number is given 1 plus 2 plus 3. These are continuous up to n. So up to n. So formula for this is 1 by 2 of n into n plus 1. Okay. If any number is given, so if the number is given, natural numbers, and they have been due to find the sum of this number, then we have to use this formula. We have to use this formula. Okay, if square is given, okay, if one square, if 1 square plus 2 square plus 3 square so on plus n square, then what is the formula to find the series of these? What is the formula? So we'll be having formula 1 by 6 of n into n plus 1 into 2n plus 1. Okay, 2n plus 1. And if we are having one cube, so 1 cube, 2 cube and 3 cube, so last the end number is n cube. These are continuous. Formula for this one is to find the sum of these numbers 1 by 4 n square n plus 1 square. Okay, you have to remember this formula because when the series is given in the form of 1 2 3 4, then this formula we have to use, and it is square of the series is given, then we have to use this formula, and when the cube of the series is given, we have to use this formula, right? Understood. And one more concept is that you have been studied in 10th class, right? Arithmetic progressions, right? Arithmetic progression and geometry progressions, right? Geometry progression. I just recall the those progressions. So in arithmetic progression. So arithmetic progressions, we know that a is the first number, a plus d is the second number, a plus 3d is the third number, and so on. So these are in AP. We are saying as these are in arithmetic progression. So what is the D is here? D is the difference, right? D is the difference. So D is the difference of what? The D is the difference of D is the difference of last number minus first number. Difference means last number minus first number. So that is the difference. So here, so suppose I will give you example here. So 2, 4, 6, 8 is given. So what is the difference here? 4 minus 2 is 2, and 6 minus 2 is 2, and 8 minus 2 is 8 minus 6 is 2. Here difference is same. Okay, difference is the same. Here difference is the same. So that one we are calling as a 2. Okay, so that one we are calling as a 2. So then if suppose if we put this d is equal to in this number, suppose a is 2. Okay, a is 2, and a plus d is what? A is 2, and 2 plus 2 is 4, and 4 plus 2 is what? Okay, so therefore we are writing here a plus d, a plus 3d. So these are the a plus 2d. This is a plus 2d. Okay, a plus 2d, a plus 2d. So here, okay, here to find nth term. So in arithmetic progressions, to find nth term, so what is the formula? So for the formula is a plus n minus 1 into d. So a is the first number, d is the difference, n is the last number. So n is the, yeah, n is we have to find. Okay, n is the last term. Okay, n is the, so n is the number. So n is the number. So nth term is means tn. So this tn is last number. Okay, first number difference, and this is the number we have to find, and tn is the last number. And what is the formula for sum of n terms? So what is the formula for sum of n terms in arithmetic progressions? N by 2, n by 2, 2a plus n minus 1 into d. Okay, and then okay, this one you understood, right? Now we'll be writing arithmetic geometric progressions. So so geometric progressions will be in the form of what? A into ar square, ar cube, right? So ar to the n, ar to the n. So what is the formula for here n term? So Tn is equal to a raised n minus 1, r raised to n minus 1. So this is the formula for the Tn, nth term. And what is the formula for sum of n terms? So sum of n terms, so sum of n terms, there are two formulas that we are having. So we a into 1 minus r to the power of n divided by, so 1 minus r we are having 1 minus r here. It is the condition for when r is less than 1. R is less than, and what is the formula for r is greater than 1? A into r to the power of n minus 1 divided by r minus 1. You just remember that when r is greater than 1, r first comes, r, no, r raised to n minus 1, r minus 1. So r minus 1 is here, r minus 1. When it is less than 1 minus r. Okay, these formula are very important. Okay, just remember the geometry progression and arithmetic progression formula and series formula. Okay, total how many formula we are having? 1, 2, 3. So the 3, and here 4, 5, 6, 7. 7 formula we have to remember. Okay, so now so I will be giving example here based on the some based on this some problems. So here I will be giving a example. So example, how many natural numbers? How many natural numbers we know that it contains 1, 2, 3, 4, 5 other than 0. So how many natural numbers are between 17 and 80? How many natural numbers are between 17 and 18 which are divisible by, which are divisible by which are divisible by 6, which are divisible by 6? Okay, how to solve this one? So now we can write here between 17 to 18. 17 to 18 means so between 17 to 18 means what? Next after between 17 to 18 means 18, 19, 20, 21, 22, 22 up to 17 nines. So these are the numbers between the 17 and 18. So which numbers will be divided by 6 here? 18 is divided by 6, right? 6 3s are 18. 19 will not divided by, then here first number is 18. Okay, first number is 18. First number 18 we got. Then we have to here divisible by 6 means 6, 6 plus 6 plus 6 difference we have to give 18 plus 24, and right, 24 plus 6 is what? 24 plus 6 is the 30. So 36, this number will be continue and up to 78 will be getting, right? 78 is divisible by 6, right? It is divisible by 6. Now what we have to do here, first number is what? 18, and difference is what here? Difference you just check here, all over is same 6. Okay, all over is same 6. Difference, how we can find this difference? Last term minus first term. So last term is 24 minus 18. So we are having 6 is difference here. And the last term, last value, so yeah, this is L, last value. Last value is 78, right? Last value is 78. So therefore we will be having L, this will be giving a L. Now what is the formula for nth term? Nth term, this last term is also equal to Tn. Okay, the last term is also denoted by Tn. So Tn is equal to 78. So what is the formula for this is, so this given problem is in arithmetic progression, right? It is in arithmetic progressions. A plus D, A plus 2D, right? It is in arithmetic progressions. So what is the formula for arithmetic progressions? Tn is equal to A plus N minus 1 into D. So Tn is equal to N minus 1 D. Tn is what? 78. So first value is 18 and N we don't know that one. We have to find minus and 6. D is 6. You simplify this equation. You simplify this equation. We'll be getting, okay, we will be getting n is equal to 11. N is equal to, there are 11 numbers are present between 17 and 80 which are divisible by 6. Okay, this type of problems will be finding by the arithmetic progressions and geometric progressions. Understood? And one problem I will be giving here based on the geometric progressions. So find the sum of, well, find the sum of 2 square and 2 cube and plus 2 raised to 4 plus 2 raised to 10. So this is in sum. It is in the form of sum. So suppose you say here a is 2 and suppose a is 2. So here it is 4. 2 square is 4. 2 square is 4 means what? A into R, it is in the this is 8. This is 2 4 is 2 4 8, 16. 2 4 6 8. Okay, so after doing this, okay, what value will be having? 2 4 plus 8 plus 16 we are having. So this is in geometry progression, right? This is a series of sum of the, it is in the sum but it is in geometry progression, right? So geometric progressions, a into R, right? A is 2 and here a is 2 and R is what? R is, we have R is 2. 2 into 2 4 and here 8. A is okay, AR. So this is in geometry progression. So now what we have to do? R is what? So R is previous value. This previous value divided by last value divided by first value. 2 by 4. R is 2. R is 2. Then required sum is here. So R is 2 means it is greater than the 1. So what is the formula for greater than 1? When the sum is what? A into R to the power of minus 1 divided by R minus 1. This formula, R is greater than 1. Okay. R is, okay, this formula we have to use A into raised to R to the power of minus 1. This formula. Okay. Then put the value of here, put the value of A is 2 and 2 is R is 2. 2 raised to N is what? N is 10. So N is 2 raised to 10 is given here. 2 raised to 10 means N is 10 here. Okay, 2 raised to 10. So and then minus 1, 2 minus 1. When we solve this, we'll be getting 2046. Okay. Okay, such type of problem will be solving by arithmetic progression and geometry progressions. Okay. Okay. This is topics are very easy. You just try to practice these things. Okay. In next class, we come with the next concept, which might be very interesting. And now I will be stop this lecturing hour. Okay. Thank you for watching the video. Please subscribe the channel and hit the bell icons for the notifications. Please do share with your friends and please please like the video. Thank you.